Alright, hello guys. Welcome to the last thing we have as a lesson until our final. So this is the last topic. Basically it's just properties of exponents. So anyways, as I always do with this, I always start off with something. So I don't know if you guys know what fruit this is, but it's a durian and it's common in Southeast Asia and it's about 15 to 20 pounds each one. So imagine these 15 to 20 pound things with spikes on them just hanging from trees. So every year people actually get hit by these durians and get pretty seriously injured. And I don't know why that's funny, but it tastes pretty good and it smells really bad. It's an Asian thing. But if you guys ever see it in an Asian supermarket, you should try to buy like a little piece and give it a taste. It'll smell pretty bad though. Alright, so today we got properties of exponents, and I'm going to go ahead and show you the exponents just really straightforward. Alright, so let's start off with the most simplest one. If I do something like x to the fifth power, y to the third power, and then times x to the second power. Notice that it's all multiplied. Alright, the thing is, you're multiplying. So you're multiplying everything, so you do the multiplicative property. So when you have this, it's really x 5 times four, 5, then y 3 times, then x 2 more times. So now you can count how many x's you have. You have 1, 2, 3, 4, 5, 6, 7. So you have x multiplied by itself 7 times. That'd be 7. Alright. Times y. How many times is it multiplied? 3. So that's the multiplicative property. So when you multiply with the same base, you just add the exponents. Alright, now I made another one. So this is the division property of exponents. So the only things with similar bases here are these x's. See, both of them have x's. So I'm going to go ahead and expand this for you. It's going to be x multiplied by itself 3 times, and then y multiplied by itself 2 times. Okay, it's y squared all over x 2 times. Alright, so what happens is you have the x's that cancel out, x also cancel out. So you have x 1 time, y 2 times. And that's your division property. Basically what you're doing is you're subtracting 3 minus 2. They have the same base, just do 3 minus 2. Alright, so now I'm going to do negative exponents. So when you have a negative exponent, you have something like x to the negative third power. What that really means is that you have 1 over x to the third power. So you take the reciprocal, which is 1 over x, and then you change this power from negative to positive. So I'll go ahead and do the same for this one. It becomes x to the fifth power, and the y didn't move, and then the x to the negative 2 becomes x to the regular 2. Okay, so it reciprocated, okay, flipped over. Alright, so now you guys know the shortcut. You can subtract 5 minus 2. So you get x to the third power, y to the second power. Alright, so here's the last thing. Let's do one where it's with an exponent of an exponent. So let's do x to the third power, y, z to the negative second power. We're going to take all of it to the third power. Okay, so the way you think about it is you have 3 sets of x to the third power, y, and then z to the negative second power. And then you have another one, x to the third, y, z to the negative second power. And then another one, x to the third, y, z the negative 2. Okay, so you have 3 sets of x to the third, y, z to the negative 2, 3 of them, because it's to the third power. And now we can go ahead and combine the x's. We have x to the 9, y, how many do you have? 1, 2, 3, 3 of them. How many negative z's do you have? Well, you have z to the negative 2 3 times. So adding them all together, you have z to the negative 6. Okay, and you could have done it like this too. The shortcut is just multiply all of the exponents. So negative 2 times 3, this, since it's invisible, is a 1. And the last one will be 3 times 3. And that gives you x. 3 times 3 is 9. Y, 1 times 3, y to the third. And then z, negative 2 times 3 is negative 6. And there's one more step we can do to both of them. Is just x to the 9, y to the third power. And since this z is to the negative 6 power, I go ahead and put it reciprocate it, z to the power of 6. And that would be on the denominator. So x 9, y third, z plus 6. Okay. And here's my last example. This is like a hard one. So let's do the top part first. That's going to change to x. I go ahead and multiply 2 times 3, that's 6. Y, well, there's an invisible 1, right here. 2 times 1, 2. Z to the negative second power, well, it becomes z. Oops, sorry. This is a 2. Okay. Z to the negative 4. Okay, and then you also have x to the negative 6th. And y over 2 on the bottom. Right from the get-go, you can already cancel this y over 2 because there's a y over 2 on top. So now I'm going to combine x to the 6th and x to the negative 6th. Well, they're going to cancel each other out, right? Because we have the multiplication, they have same base, they're being multiplied. You just take the exponents and add them together. 6 and negative 6 give you x to the 0. Anything to 0, it's just 1. So it does nothing to us. We're just left with z to the 4th power. And since we have that, z to the 4th power gives us, oh, it's an ugly arrow. Z to the negative 4th power gives us 1 over z to the 4th power. And that's it. And that one pretty much combines everything. You're multiplying, dividing, power of powers, and negative exponents. So that pretty much covers all your bases. There's 9 problems that are these on the final, so that gives us about 20% of the final is this stuff. And they're all pretty easy, so you guys should be able to do them as long as you're focused and you watch this video. So this is the last new stuff we'll learn until we start the new semester after break. Okay, the final is in the week after when we come back. So after we come back, we are here for a week and then we have the finals. Alright, that's it. Good luck studying.